Hello friends. So I'm back with organic chemistries chapter 2, that is naming of alkanes. Okay, so I have done the introduction part already, and this is the second video that I'm making. So in the introduction part itself, I had talked something about alkanes, if you remember. Okay, I'll discuss this also over here in this video as well, but this is an important thing, okay, because see, this is a part of hydrocarbons. So let's go ahead and let's see what are the contents, and then we'll come to the content itself. Okay, so now see, in the contents we'll first see introduction, then naming of alkanes, step 1, step 2, step 3, step 4, then conclusion. Okay, so now let's go ahead with the introduction. So now over here, what we have to understand is, first of all, what is an alkane? Okay, so let's understand what is an alkane. For that, you must understand about types of hydrocarbons. Types of hydrocarbon. Okay, so what are the types of hydrocarbon? There are 3 types of hydrocarbons. One is alkane, one is alkene, and one is alkyne. Regarding alkene and alkyne, I will discuss in the next video, but today the main focus is about alkane. Okay, so let's understand naming. I'll be discussing about the naming as well, but before that I want you to understand few things about alkanes. Just a minute. So what do we need to understand about alkene is, see, if there is a carbon chain, let's say it's C, H, 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 can you see this carbon is connected by single bonds? Yes, so since the carbon is connected by single bonds, that is the reason in the naming the suffix will be ane. Okay, that is ane. If there are double bonds, then it is the suffix will be ene, and if there are triple bonds, means even in one carbon if there are triple bonds, then it will be called as yne. Okay, so this much we understood. So let's go next. Now naming of alkanes. So some common thing I'm going to tell you over here, and then we'll start with the steps. Okay, so what are the common things is, first of all you need to understand that if there are carbon chains, let's say if it is C, H, 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 H. Okay, so what is this? If there is single carbon, the prefix will be meth. Single bond, that is written as ane at the end, so it becomes methane. Okay, if suppose there are two carbon atoms, so its its prefix will be eth and single bond, so ethane. Okay, so in the same way, if there is three carbons, it is called propane. If there is four carbon, it is called butane. If there is five carbon, it is called pentane, and so on. Okay, so this much you must understand. So in short, I will write over here: one carbon meth, two carbon eth, three carbon prop, four carbon but, five carbon pent. So we understood this as well. Okay, so let's go ahead with the steps of naming. Step 1: find the parent hydrocarbon. So what we have to do, hydrocarbon, like again we come to the name meth, eth, prop, but, what it should be. Okay, so for that there are two parts. Find the longest continuous chain as the parent name. Before that, we'll understand one more concept. Okay, before that we'll understand one more concept, that is substituents. Sometimes there are carbon chains and there are branched chains as well, like from one carbon another carbon is getting added. Let's see, let's take an example of C, 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 C. So here again it is C, here H3, H, 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 okay. Now can you see one thing, that there is one methyl. Now you need to understand what is methyl. I have discussed in the introduction part, but I'll just give you one straight example of that. Whenever we take out one hydrogen from any ethane, methane or alkane, it becomes alkyl group. Alkyl, what is this? Is methyl group, CH3. Okay, if it is C2H5, it becomes ethyl group. So that's what CH3 is there. So this is methyl group. Now we need to first find the longest continuous chain. Now if you check over here, let's calculate which is the longest chain. We have to consider the chains as well, okay, because sometimes that gives you longest. Now only longest chain will be the main continuous parent name. Okay, that is meth, eth, prop, but, anything. So let's start from the left hand side. So 1 2 3, if we take this 4. Okay, 1 2 3, if we take this 4. Okay, from here if we count 1 2 3, no, 4 is the highest number. So you can either take like this or you can take like this, anyway. Okay, or you can take like this. So either you can take here 1 2 3 and 4. So let's take like this only. After this, what you have to do is let's check the second rule. Okay, according to that, this should be the longest chain, so we did it like this. But there is another rule that says if two chains of equal length are present, choose the one with larger number of branch points as the parent. So if there is a larger branch points, right, we take that as the parent. Okay, if there are suppose cs3, there would have been one more cs3. So that at that time we had to take that as the parent name. Okay, so that is the consideration. Now let's understand about that. In the step 2, there is one thing more which must be added. Now number the atoms in the main chain. Now we have to number it, beginning at the end nearer the first branch point. Number each carbon atoms in the present chain. So suppose, let's take that example itself. Construction is a big difficult task. Now we could actually count from this side. Once again, we could have done the numbering like we did last time, 1 2 3 4 or 1 2 3 4. Okay, so if we take as 1 2 3 4, okay, so the methyl group, the substituent, has to be nearest to the carbon, and then the numbering should be done. So if suppose if we check the number of this methyl group from left hand side, 1 2 3 4, or let's say 1 2 3 4, then what happens, this methyl group gets the number of 1 2 3, carbon 3. But if we see from here 1 2 3 4, then it is getting the number 2. So that is the reason the numbering won't start from left to right, it will get started from right to left. 1 2 3 4. Okay, so like this. Now the name, let's try, let's go ahead in the third rule, we'll understand about the naming. Okay, identify the number of the substituents, assign a number called locant to each subsequent to specify the point of attachment to the parent chain. That is what we learned right now. How we identify the substituent? We numbered. CH3 was methyl, so we numbered it as 2. Remember? Okay, so now let's go directly to the step 4. Over here, write the name as a single word. Now we have to write it. So the same example which we were going through, we are going to name this compound, okay, using all the 4 rules. First of all, we have to name, in the name we have to write about the substituent. Okay, so what is the substituent out here? This methyl group, and it has the number 2. So how it will be written as, and since all are single bond, you can see that no double bond are present, so what we will write out here, we will write first the number, at which number the methyl group is present, number 2, dash what is present, methyl. What is the number of carbon atoms out here? One maximum number of carbon atoms, 1 2 3 4. 4 means Bute, bute, and all are single bonds, so ANE. So it becomes 2-methyl butane. Did it make sense? Or I think you must have understood now how can naming be done. Yes, now I'll give you one more example to make one thing clear. Okay, if suppose it is not difficult, just there should be no confusion about it. So that is the reason I'm writing out here. Okay, so let's find the longest chain. So longest chain, let's count from here. 1 2 3 4. No, I think it is not, but let's keep it as here 4. Okay, then 1 2 3 4 5 6 6. Okay, then 1 2 3 4 5 6 6. Again count from here. 1 2 3 4 5 5. Again 1 2 3 4 5 5. Okay, and 1 2 3 4 5 6 6. Okay, so 6 is the highest. We can either take like this or like this or like this. Now how to name it? You can see that methyl group is the number 3 and ethyl group is the number 4. Ethyl, why ethyl? Because there are 2 carbons here, 1 carbon, so methyl. So ethyl group is in the number 3. If we count from here, ethyl group gets the number 3 and methyl gets the number 3 and ethyl group gets the number 4. Yes, and if we count from here, ethyl gets the number 3, then methyl gets the number 4. So what happens out here is, first let me erase this. Okay, wait, let me just erase this. Yeah, so now whenever we have to check the preference, whom should we give the preference first? So always go according to the alphabetical order. So for methyl it is M and for ethyl it is E. So E comes first in the alphabetic series, then M. So that is the reason we are going to give ethyl group as the first precedent. Then so that is the reason we are going to number from this side. So it will be 1 2 3 4 5 6. Okay, this much is on. Okay, and while writing also, what are we going to do? First we'll write the ethyl. So 1 2 3 number, right? So 3 ethyl, then 4 methyl, methyl. Now how much chain is there? 1 2 3 4 5 6 means hex, hex, and single bond then 8. So what is the name? 3 ethyl 4 methyl hexane. Okay, so just to clear up this concept of how to give preference, I told you about this alphabetic way of numbering. Okay, So I hope this is clear. So in the conclusion, in this class we observed the steps that are used to name a simple alkane. Okay, I hope it was of use. So thank you so much for coping with me and understanding the concept. Okay, thank you very much.